In this example, we're going to solve an equation that has multiple variables in it. Our equation is a equals p parenthesis 1 plus I over 100 close parenthesis raised to the second power. So we've got these three variables, a, p, and I. But the equation for this problem, they ask us to solve the equation for only one variable, I. And for that type of problem, you have to just consider all the other variables as numbers. Just pretend they're numbers and go through the steps that you normally go through to solve, in this case, a second degree. It may be a second degree equation. Well, it'll be a second power equation. You'll see that we get to that when we are in the process of solving it. So ignore the other variables. I mean, just assume that they're numbers and constant numbers, and then treat the I as though it is the one and only variable. Okay, so the way we're going to do this is we're going to isolate the term that contains the I. Isolate the I term. So first we'll have to get rid of the, well, let's turn the whole thing backwards. Let's put the 1 plus I over 100 to the second power on the left equals A. And divide both sides by P. In this process, we actually got rid of the number P because we were trying to isolate the term that had the I in it. So we divided both sides of the equation by P and turned the whole thing backwards. Now we need to get the I, which is locked up in the parenthesis, out on its own. And we need, in doing that, we need to eliminate that second power. So to eliminate that second power, we're going to take plus or minus the square root of both sides, plus or minus because it's an even index, this 2, the power 2. So we have 1 plus I over 100 equals plus or minus the big, tall square root of A over P. Now we're going to isolate the I term. To isolate the I term, we're going to move 1 over, so subtract 1 from both sides. All right, we're almost there. Let's go ahead and get rid of the coefficient 1 over 100 by multiplying both sides by 100. And that leaves us I equals negative 100 plus or minus 100 times the tall square root of A over P. Now, if you simplified this, you might have written it a little differently, and it's equally correct. It's the same answer as I equals negative 100 plus or minus 100 times the square root of A times P over P. That's the result of actually getting rid of the radical in the denominator, rationalizing the denominator. But it's equally correct, the first method or the second method.